So let me invite here to the stage our speaker with whom we would close this conference, basically. And this is Jessica Kerr. Jessica, welcome to Java on 2024.
Thank you.
It was really nice having you here with us. So can you give us just small highlight what your talk would be about?
Yes, my talk is about how we deal with managing more and more complex software. As an individual software engineer, we're constantly asked to do more. So how do we do that? And one answer is we get the software to tell us what's happening so that we can understand it and fix it more efficiently.
Yeah, I can say that this is a very important topic. In 1 week, it's Black Friday, and I'm really waiting for my software to tell me if something will go wrong. So, guys, I want to remind you last time that you can put your questions in the chat where you're watching us. Well, I'm reminding Jessica, may I ask you to share your screen? And yeah, so to ask your questions on YouTube chat, ask your questions on our community platform. I will collect all of them and ask them in the end of the talk. So yeah, we are nearly ready. Once Jessica will share your screen, we will show it on the stage. Yeah, guys, all your questions are appreciated. I do hope you receive a lot of useful information on our conference, and I do hope that you will be able to use it. Now we can see the screen. I will ask our operator to put it on screen. Great.
Fabulous.
Okay, so yeah, good luck. Stage is yours.
All right. Great. Yes. I'm Jessica Kerr. Online, I'm Jessitron, and I work at honeycomb.io, which is an observability platform. And I'm here to talk about OpenTelemetry because observability is important right now. I'll talk about that for a few minutes. And then I'll do some live demo of like the difference between observability that used to be good enough and observability that's the best we can get right now. And then I'll talk about how OpenTelemetry makes that more feasible than it used to be. I've been a developer for like 25 years now. And back in 1999, when I didn't even have a laptop, I just had like this PC that sat under my desk and one of those big, deep CRT monitors. And back then, when I wrote code, I would test it to find out whether it worked. I'd like write a test harness to test my functions, and then I would delete that test harness before I committed my code to version control. And if it wasn't doing what I thought and I needed more information, I'd add some printf statements to the code, and then it would print stuff to my screen. And I still use printf statements, but I have alternatives as well now. And then I delete those printf statements too before I committed it. And that was it. That was like the extent of my responsibility as a junior developer. As my career progressed, I started being responsible for the software, like at least working with the other software, right? We get more services and more teams to work with. And now I'm not deleting my automated tests. I'm putting them into continuous integration so that my software continues to work as the system changes around it. And then I'm changing my printfs to log statements that I also can look at in integration tests. And that way, when something fails in integration test, the other teams and I can have a fight, my logs versus your logs, over who did it wrong. And that was progress. At least the log statements might help when something goes wrong in production and maybe somebody brings me the logs and I look at them. But that's not enough for me anymore. It's not enough for me that my software be correct and that the integration tests pass. As a developer, what I want is to provide useful capabilities to people or sometimes to other software, which in turn provides useful capabilities to people. My software should make something possible that wasn't before, or more likely, make something easy that's otherwise hard. And that means my software needs to embody whatever complexity it's taking away from the people who are using it. So to provide more capabilities, my software needs to be more complex. And that typically means there needs to be more of it, more smaller units, more services, more teams working together on software that works together. In order to provide those capabilities, my software needs to be running in production, in collusion with all the other software that it collaborates with. And that's what I need to accomplish my goal. So now I care not just about whether my software meets requirements and passes tests, but whether in production it's really functioning. Are people using it? Is it fast enough? Is it as fast as it was last week? Who is calling into it? Which different softwares are calling my APIs? And when mine isn't working, is it my code that's the problem, or is it some downstream? And which downstream? And how often does that go down? And when I do have an error in my code, is it important? How many people are affected? Which people are affected? I can, in theory, answer all these questions from logs, but it takes a lot of reasoning. Although I don't have access to the comment thing, or I would ask you whether you all have access to production logs or maybe APM dashboards or whatever, because I haven't usually had access to that in the past, but now I care deeply. And if I'm at a place that I can't get access to that, then maybe I can make friends with someone in operations or on the DevOps team or whoever does have access, because together we can work powerfully to improve the software and make life better for all of our customers. So I care about the system much more widely. And I'm always asked to support more and more software or else add more and more features. And the complexity goes up. And I can't keep all this stuff in my head, besides which I'm maintaining software that I didn't write. My favorite software is legacy software because it's valuable. And that's what I'm looking for. But to do that is much harder than maintaining only stuff that I wrote and still remember. So I need it to tell me what's going on. I need observability. Observability is when we can tell what's happening in our software because it tells us, because we made it tell us. It means we don't have to reason from customer error reports. We don't have to wait for customer reports. And then we don't have to listen to their story, maybe look at production data in the database and reason through what might have happened and read the code and try to figure it out. It means it just tells us. We have a piece of data that says, hey, right here, something went wrong and this was the message, and probably not what to do about it, but at least where to look to figure out what to do about it. And that data is called telemetry. So these words come out of rocket science, because like when you build a rocket and you fire it off, you don't have like some cops in airplanes with radar detectors to tell you how fast it's going. You know how fast it's going because the rocket tells you, I'm going 500 miles per hour and the wind is out of the east. And next I'm going to fire this rocket off, or this jet, because I need to adjust my trajectory a little bit like this. It like phones home to say what it's doing and why. The data sent there is called telemetry, and it's sent because of instrumentation. Instrumentation is code that's just there to tell us what's going on. So every printf, every log statement, and every like metric counter that we add, these are instrumentation because they're there just to phone home and tell us as developers or operators of the software what's happening. It works locally, it works in integration test, and it works in production. But not all observability is created equal. And what I want is really good observability. One more concept that we're going to need that like doesn't actually work with the rockets, because the rockets aren't flocking like birds, but our software does kind of. Our software is like coordinating and talking to each other all the time. And in order to tell the story of what the heck our software is doing, we need it to pass a little extra information with every message of, hey, this is why I'm asking you to do that. That's called propagation. We'll come back to that later. the core concept here is that we need instrumentation code to emit telemetry so that we can have good observability and see what's happening. And what I get out of that is feeling like the running software is not like my enemy that gets me paged on weekends. It's on my team. I want to provide useful capabilities to customers, and I can't do that alone as a person. I can't be reliable enough for that. I need all the other people on my team and probably some other people if I can't deploy it myself. And I also need that software to be running in production. It's part of how I accomplish my mission. And I also need the tools that get it there, like my continuous integration, my deployment system, my IDE, my observability platform, my tests, and whatever else I use to learn what's going on in production. Because my code is learning from me because I change it, and I can learn from it. The better my observability, the better I can learn from it. So I like to think of the running code as part of my team, and that makes me happy. Speaking of code, let's go look at some. All right, I've got a service. Let's see, we'll start it up again with Maven Spring Boot Run. And I can test. Okay, so I'm running it. All right. I can test it with curl because what it does here, clear curl again, is I call /phrase and it gives me a phrase. This one is not a bug, it's a feature. This one is test in prod. This one is you're muted. Great. Maybe I want to add another possible random phrase to it. So I go over to the code. Let's see, we're in phrase controller. Last time GitHub Copilot decided that I should add, I'm a software engineer, I don't have feelings. I changed that. No, we're going to do something different this time. GitHub Copilot. Oh yeah, we could just do hello world. That's kind of boring. I'm going to spell it wrong. That's funnier. Okay. So there I have inserted a random phrase. Now when, restart. I don't have hot reload going. So I can restart my service and then I can test it again. And I mean, it seems to be working, but did it pick up my random phrase? Why did it give me deploy does not equal release? Randomness is lumpy. That's a thing. I don't know. It could take me a while to actually get the new phrase that I added. So I need to add some observability. Okay, I could also make this more testable, but this is about production. I need to add some observability to know whether my change has really taken effect. So if I look at the code, there's some log statements in here. Oops, these are for later. There's some log statements in here where I'm printing out the size of the list and the choice. The choice is like a random index into that list. So I should be able to at least see a difference in the list size if my phrase is taking effect. Let's go see if we saw that. All right, last 4 log statements here are before request, get phrase, list size is 27, and then after request, okay. So currently the list size is 27. What was it before the last time I ran it? List size was 26. Okay, I have at least made a change. And so this log statement is some form of observability. But now let's run it in context. So if I do Docker compose up, then I'm running a little integration test of my, this one's called phrase picker, this phrase picker service in context with some other services. We see backend for front end, phrase picker, and memeinator. And then I can test this. Let's see, we'll need to be in Firefox. Here it is, localhost 8080. And I push go. We'll see if it works. It could be worse. That's my sister's puppy. And we can push go again. And we can get another meme. There we go. The screaming Clementine. And so now you see like what it's doing with the phrases. Oh, that one didn't work so well. Too bad I don't have a way to give feedback on the meme. There's a giant fork. All right, so this seems to be working, but if we go look at the logs, here's my phrase picker, that's good. And now here I'm running multiple services, but I'm doing exactly one thing. And therefore, the logs are largely intelligible. In fact, I can improve this by looking at them in, let's see, here's a local log viewer. This is Aspire Dashboard, which is a new release from Microsoft. I just found it yesterday. It's great. We can see here's our phrase picker before request. Oh, that's a list size of 26. What order are these in? I need you to query again, please. Still see a list size of 26. Oh, that's because Docker didn't build. It's fine. Please ignore that. But now I know that it's running a previous version of the phrase picker. It's not using the one that I just changed because I didn't say -- build and Docker compose up, which is because I don't have 15 minutes. So we can see the logs, but can I answer all those questions? If I want to see how long this request took, I have to subtract these numbers. And also, who called into phrase picker? I think it was backend for front end, but then I'm cheating by knowing the app. However, I'm not only sending logs here, I'm also sending traces with OpenTelemetry. So if I click on this, I get the story of the request. So this is the distributed trace, and I'm going to go into some detail about that because it's not obvious what a distributed trace is. But what it's doing is it's telling me that backend for front end Java received a post. Let's see if I can make that bigger. There we go. Good. It received a post to create picture. And as a result, it did a get to phrase picker. Phrase picker received a get. So this distributed trace is telling the full story of what happened across all services, from backend to front end to phrase picker. Here it calls it into image picker, which is in Node, different language. Distributed tracing is very cross language. And then Meminator down here is the last service. And I can see how long things took. So this whole thing took 1.1 seconds. That's not bad. Let's see if I click on traces, maybe I'll get some other numbers. Oh yeah, here, this first one took 3.74 and this one put 2.43 seconds. But I can also see what took so long. So phrase picker here took 8.46 milliseconds. As the phrase picker team, I'm fine. But Meminator is taking 2.27 seconds. Some of that is a get, and then what is it getting? I can click in to each row here, which is called a span. A trace is made up of spans. And I can see, I know to look at the URL field, and I can see that it's retrieving clementine.png. Oh, no, that's the fork. So I was looking at the Clementine, the screaming Clementine one. You can get a lot of information out of a trace. And what's more, it's all tied together. And we'll show that in a minute when we deal with Meminator in production. But first, I want to pop back over here. And yeah, we did it with many services. And explain more what's the difference between logs and distributed traces, because I don't think this is obvious. So if you had a tiny e-commerce app and it had this pathetic checkout service that receives a post to /checkout and that causes checking out, and then it calls cart and shipping and it does some database operations. Yeah, the cart is selecting and the shipping is inserting. No, actually the checking out has 3 steps: calling cart, calling shipping, and insert. Because the first difference between logs and spans, which are components of a distributed trace, is that linking between. These events are not disconnected. They're connected to each other using this propagation mechanism, because the checking out was caused by the post, and this select statement was caused by calling cart. Next difference, actually logs also tell you which service they're from. So that's pretty easy. But we do have multiple services participating. And then we have the span of time. So whereas a log always has a timestamp, a span has a timestamp and a duration. So you're covering some unit of work and describing some operation, not just a pinpoint in time of exactly one thing. Not just, hey, here's the list size and the choice, but I'm doing this whole thing about phrase picking, and it took this long. And then when there's an error, you can usually go right to it. You can find exactly the cause by looking at which one is deepest. And then while the span is happening, you can add all kinds of information to it, such as list size and phrase. And this is different from logs because logs, you're like, oh, I've got a list size, here you go. And it's not immediately correlated to like, what URL did I hit? So with this top span, the root span here, you have the URL at the beginning, but you don't have the status or the errorness till the end. And somewhere on there, we're sticking the CPU usage just so we can correlate that later with how long it took. You can add this information as you go so that it all gets in one place and you can do all kinds of analysis and correlations on it. So this one post is replacing 4 or 5 log statements, however many, at least a start and an end, and then however many in the middle you would have used to print these out. Oh, and then they all have the same trace ID. So there's one correlated story so that as you scale up, you can still see stuff. You can still tell it apart. Okay. And then there's all kinds of attributes on the spans, which we can check. Let's go look at ours. Here we go. So in get/phrase, I can see the span ID. Every row, every trace span gets a span ID of its own. They all share the same trace ID. Where's that? Trace ID is this 2F. And also, most of them have a parent ID. Parent. Where is it? Okay, so this one's parent is DB701 something, which tells me that, so that one has a different parent, but what's your span ID? Span ID is, where'd it go? There it is, DB701 something. All right, so this is the parent span of that one. And that's how this linking together works. Also, this one from back end to front end has a kind of client because it's calling out. And then this get/phrase has a server because it's receiving the request. This top one, which is called the root span because it represents the entire request from the customer's perspective, or as close as we can get to it. I don't see the network latency here, but this root span is the only one, is a kind of server, it came in, that doesn't have a parent ID. And that's how we know it's the top and it represents the whole request. So that's how they're linked together. And then there's all this normal stuff that is added automatically, the get/phrase, or not the phrase, the get/phrase, yes, because that is the URL that it came in on. But this app.phrase and list.size and our choice, those were not created automatically. We saw those here. Those came from here. And I can bring that in from OpenTelemetry. So this is instrumentation, manual instrumentation that I wrote because this information is important and it replaces these log statements really. And all of this is, I mean, it's technically possible without OpenTelemetry, but it's much easier because I'm using OpenTelemetry. All of that distributed trace was very little work because a lot of people have worked really hard to make this easy in the last 5 years or so. So OpenTelemetry recognizes that in today's complex software, distributed tracing is really useful. Also, logs and metrics can use some standards, and it has those as well. But especially distributed tracing is really hard without OpenTelemetry. OpenTelemetry is an open source project. Really, it's kind of an umbrella over many projects. So there's protocol specifications, there's naming conventions, an API to write that instrumentation that I just showed. And this is across languages and it's across frameworks. OpenTelemetry is also part of the Cloud Native Compute Foundation, which is like a very official, and there's governance committees, multiple ones, and there's ambassador programs, and there's change request processes and working groups in so many meetings. Okay. A lot of people are spending a lot of time making these standards so that we can build on top of them. It's the second biggest project in the CNCF by a lot of measures. I think it might be first by number of contributors by now. But the first biggest project that the CNCF is most known for is Kubernetes. So OpenTelemetry is very serious business in open source. This is not somebody's hobby project. I mean, it's many people's hobby project, but then they're coordinating and doing a lot of work. There's foundations and yeah, there's a lot of stuff. And all of this so that we can more easily write instrumentation to get telemetry that gives us clues about what's happening. In particular, OpenTelemetry provides a standard for the format of the data itself, ensuring compatibility on both ends. That is called OTLP, which stands for OpenTelemetry Protocol. I don't know where the L comes from. And also the instrumentation code that emits data in that format. Because I don't have an OTLP receiver in my brain, the data doesn't actually flow straight into my head and give me clues. So it's a little more complicated than this. Once you have that telemetry data, you have to put it somewhere. You have to put it in a database. And then to get the clues, you have to query that database. So this whole part of storing the OTLP data and then querying it and displaying it to users and letting us ask questions, letting me ask how long does it take, letting me ask which errors are important. That is the responsibility of an OpenTelemetry backend, which is not actually written in, not part of the OpenTelemetry project. It's compatible with OpenTelemetry. The good part is there's lots of choice here, maybe too much. So you can use an open source tool like that Aspire dashboard, which is really just for local, or the Jaeger is a CNCF distributed tracing tool that we'll see later. There's open source tools for logs and metrics, or you can use a vendor, and all of the observability vendors except OTLP. So Datadog, New Relic, Splunk, Sentry, Honeycomb, of course, which is the best. That's why I work there, see. But we all accept OTLP. And one of the beauties of that is that as a vendor, we have to continually work for your business. We can't just say, oh, well, our agent is embedded in your code, so you must stay with us and pay us millions of dollars every month. So having standards and flexibility is really good for competition in the industry. And I think that's really pushed our standards of observability even higher. So that's one reason that OTLP is really great. And everyone should move to OpenTelemetry because it gives you this flexibility. You can start with a SaaS platform and then move to open source if you don't like it. Take your pick. The way it does this is by providing code in every language that implements they call it the OpenTelemetry SDK, which is an implementation of the OpenTelemetry API. And it lets you do things like start spans, add attributes to the span, and end the span. But mostly you don't want to do this, actually. Oh, yeah. And then there's like keeping track of that span in global space, which is different in every language, and every execution flow. So different, like the Akka will do this differently from WebFlux, but All of them use thread locals at some point in Java, but it's different in every language, how we make that span available globally for the set attributes. You don't want to have to worry about that. The OpenTelemetry libraries worry about that. And even more, they do the start and end span for you. Because if your application, say, calls out to a database, and maybe it's an HTTP server, so you're using frameworks and a client library for the database, OpenTelemetry has projects that know about each of these. And then they do bytecode injection to add instrumentation around those libraries so that when you make a database call, it creates a span with kind internal and the db.query populated with your query string, but not the parameters, because those might contain private information. But as long as you parameterize your query, you get select from table where question mark, question mark. It's really useful to have that information. And it all goes onto the spans. And then that gives you the sends wherever. Oh, and it does the propagation for you. So this is giving you the structure of the distributed trace, because OpenTelemetry libraries plug into your HTTP client library, among others, and they add a header, an HTTP header called trace parent, that includes the trace context, which is the trace ID and the current span ID, to say, hey, this is why I'm asking you to do this, link your events up. So that server span, it's a client span, from, say, backend for front end, gets this header injected onto it. You don't have to write any code for that. And then, and the web server library, so Play or WebFlux or MVC, whatever, the instrumentation that injects code into that library will pull that header off and start a span that is a client span and has the same trace ID, and the incoming span ID is its parent. And this is how we link it all up. Propagation is kind of magic. And there's standards for gRPC, metadata, and for Kafka and various other communication mechanisms. So only if you have something custom do you have to worry about passing that metadata along yourself. So that all comes from OpenTelemetry. And this is how you get that working in your software. So I can show you like my Docker file. Here's a Docker file. The easiest way to use OpenTelemetry in Java, and the recommended way, is like from the outside to inject this Java agent, which like digs around in your code and injects whatever it can inject as part of the Java command line. And that Java agent is downloaded from GitHub OpenTelemetry releases. Here's version 2.90. And then it's configured in environment variables. So I just have some simple ones here. Here's where you should send the data. This service is called phrase picker Java. And also send me the logs in OTLP log format. And it'll like attach trace IDs to logs so that your logs can be linked up to the trace later. It's really cool. Okay, I think I might have done a tiny bit of log configuration to make that work, but mostly just turning on log4j. Right, so you can also configure a lot of other things like use this instrumentation, don't use this instrumentation. Like the Redis one can be noisy. Some people turn that off. This function that I wrote, make a span around it. All kinds of interesting things you can do just in the environment variables, especially in Java, that's super powerful. Okay, so that's how you get OpenTelemetry to work. It's just this. And that gives you like the whole outline of the trace. And then we've seen what was in those spans. And then you can do that little bit of custom code to add the fields that are important to you. Now, in this case, whatever the choice, the list size, not super interesting. But in real life, you want customer ID here or user ID, not their email address, because that's PII, but their ID that's only meaningful inside your system. So you want to know who these errors are happening to. You want the stack trace in here if there's an error. You want all kinds of things, especially what's valuable to your business. If you're multi-tenant, this is hugely important because every tenant is having their own experience and you want that tenant ID on your trace. So a little bit of code goes a long way there. And that's called custom instrumentation, where you just call set attribute, like I did in the phrase picker, to put your custom stuff on there. And so this little line of code really decorates and adds value to the wider outline. Oh, and here's the dependency. So like to add the Java agent, I don't have to even like change my POM or my Gradle file at all. Well, unless you're telling Gradle to start it up. Only include the OpenTelemetry API in your application code. And then if the Java agent doesn't get attached at runtime, then these are all no ops. All those set attributes and stuff, they're all just no ops. Oh, and this is the bomb that makes the version number be populated when I put this in my POM. So dependencies, they're so hard. Right, but only bring the API into your software. You don't even have to bring the implementation code. Okay, and the beauty of distributed traces, the premise is they scale up to production. So please go here. You can scan the little code or the barcode and do this on your phone if you want, or you can go to jessitron.com/meme and it will redirect you to a longer URL. This is fine. And run the Memenator and let's see what happens in production. And we'll see what's going on with it. Okay, let's see. Here's a Memenator. Go. Let's get the network tab open and clear it so I can see what's going on. Go. Aha. Okay, it's working. Y'all haven't broken it yet. This is running in my own toy EKS cluster. No guarantees. I do not have any SLAs for Memenator. But see what you can get. Oh, there's an error. Okay, I got an error. That's fine. There's the giant fork. All right, now let's see what's happening. If I go, the shortcut is jessitron.com/otel/Jaeger. You can go here too, because this is open, because this data is very not sensitive. And you might break it. FYI, this is like in-memory Jaeger instance, and when it gets full, it falls over, and Kubernetes restarts it. Okay, so when you get to Jaeger, you want to click on search and then choose the phrase picker and do find traces. Yeah. Some people have been clicking it. Good. I didn't make all of those. And then we can click on one of these. Oh, in here, I think that the higher ones are slower. There's duration. Oh, there's a failed one. We can look at where it failed. Oh, yep. The lowest error is in Memenator Java. And it says this get failed. And this one always fails because it's got spaces in the URL, and that one doesn't actually work. So I'm not seeing, this doesn't give me a good error message, but it does tell me at least what URL I failed to retrieve. And then I can go copy this and throw it up here. Oh, wait, I don't want to lose that window. Throw it up here. Oh, it actually works from the URL bar. So yeah. What's your problem, Memenator? Where was I? Okay, I was at this trace. But you can look at what took so long. Now you may notice that in this version, in the production version, Memenator Java has an extra span because it's taking forever. It's taking 1.29 seconds here. What all is it doing? 314 milliseconds are a get. One of the other things it's doing is running this convert command. And I got that by adding Memenator controller, this single annotation says create a span around this function. Now that's a Spring thing, and required an extra import, but it gave me a span because this is an important unit of work in my operation. I'm actually calling out to the shell, so it should definitely have a span. And then I think I add an attribute to it. Oh, and the standard out, I added some more attributes down here. And then I ended the span. It's very important to end your span. You don't get telemetry for creating spans. You get it for ending the span. That's key if you're going to do this. Wait, I should actually, that's wrong. I don't have to end that span because Spring is going to do it for me. There's a different way to create spans that I must have been doing earlier that you have to end it, but Spring is going to do it for me with this annotation. And well, the OpenTelemetry code that integrates. Okay, so let's see what else we can learn about what's happening in production right now. We saw some traces. Let's see. Can I search again? Find more traces. Yeah, there's a few more. I can't look at logs in Jaeger, but I can in Honeycomb because I'm also sending this data to Honeycomb. So let's look at logs for the last 10 minutes. And I can see, yeah, there's a bunch of stuff happening in Memenator Web and Image Picker and Backend, but it's really hard to follow like any one thing that's happening. Let's look over here. Show me some of the new ones, view events. There's just a few. It's really hard to find out what's going on from the logs, whereas a trace makes a clear picture. So this is why I think traces scale a lot better than logs. There's also different ways to like cut down your data volume because I can save whole traces and keep whole stories instead of random logs that I might never get the whole story if I drop random logs. But dropping carefully chosen traces is quite, ooh, look, did we get an error right here? Check this out. And here's here's a debug log right in with my span, and it has a bunch of stuff on it. What does it say? I don't know. I'm not sure. I don't think this is actually an error. I think it's just pink because pink is pretty. But you can integrate the logs directly with the spans, and that's handy. I like that. Right. And then you can say, okay, oh, check this out. Check this out. This trace actually started in the front end. And so my post from Memenator Web, which is what we're seeing over here, took 7 seconds. Whoa, that's really long. But my backend only took 2.3 seconds. All this rest is network latency. So this is a pretty good picture of customer experience and how we can optimize even Memenator all we want. But really, maybe we should be like running in a CDN or someplace other than my toy EKS cluster that doesn't get its requests fast enough. And we can also ask, like, is this normal? Is it normal for us to take 2.3 seconds? And okay, I can't do this in Jaeger either, but I can here. Because if I have all this rich data like phrase and image URL is one that shows up in the Memenator, then I can correlate that with slowness. So like this graph is going to tell me what's slow for create picture calls. Y'all aren't hitting it very much. I'm going to have to go hit it some more. Last 10 minutes. Oh, there we go. Okay. And I can say like what happened with this 8-second one. I bet it was network latency. Yeah, view trace. No, this one, no, that one was just 3 seconds. I clicked on the wrong dot. This was Memenator. Anyway, I can also say like which images were slowest. Look by image URL. And a real heat map was fast, probably because it failed. Oh, I'd have to get, look at the P90 or the max duration. Being able to query over these makes it more fun. Okay, so the slowest one was Bigfoot in this case. We only got one of those. And there's some correlation. Anyway, tracing, amazing. You can do it in multiple tools and you get the whole story of a production request, and this scales up in a way that logs, where's that logs picture? Oh, I've clicked into something. Here's some logs. The logs really don't. It helps me get oriented in what my software is doing where. Show Jaeger. And it really helps me understand what's happening in my production software in context of the other software. And this used to be incredibly hard and take an amazing amount of manual work through your system. But with OpenTelemetry, it's completely feasible. Yep, there's the POM bit for the annotation to create a custom span. Overall, thinking about observability means asking my software to do a better job at telling me what it's doing, not settling for what works locally, but expecting to test in production. And even if I'm not allowed to run tests in production, my customers are constantly, I would like to look at the results and have them be meaningful. So I have instrumentation, I have telemetry, and even if that's just logs, that's fine. I can use a log aggregator to read them. Or if I have APM and it's just counters, then I can't know, like, okay, which customer was it slow for? But I can at least know whether it's slower than last week. That's something. And then with distributed tracing, I can get all that detailed information and the troubleshooting. And if you combine all three of them win. Recommend. In any case, I want to think about my software as part of the team and make it really productive. OpenTelemetry is an industry standard. It's super solid. Everyone's moving to it at some rate or another, if nothing else, because their observability is too high and they want choices. But Java has the best OpenTelemetry support of any language. So as a Java dev, you're uniquely positioned to work with this. Oh, yeah, you can, like, I think I Googled OpenTelemetry Java support. They have a whole list. These are the libraries that we have instrumentation provided for. And I'm still in the A's. Okay, I got to the E's. It's a long list. You can also go to the opentelemetry.io/registry and find there. You can look for any language and any library. You can look at the repositories directory. OpenTelemetry Java is the base API and SDK. And then Contrib has a lot more instrumentation in it. And also like more exporters and stuff like that. You can do this locally. The Aspire dashboard in particular is pretty easy to run locally. It's a Docker container. And so you can run with the Java agent attached to the services that you can run locally and see it. And then it's also really useful for reducing build times by like finding the slow tests. There's lots of things you can do with it in addition to production. If you can't send your production data somewhere, that can be hard. This is how I have to change Maven to get it to start up correctly for Spring Boot. And then if you really want to understand it, learning OpenTelemetry is for people using OpenTelemetry. It has all the different concepts in the API by my coworker, Austin Parker. Overall, observability is an important part of a healthy production software system. If you don't have it, every incident is worse because it gets you to the root of an error quickly. And also you can measure the impact of an error. Very useful. When you're serious about OpenTelemetry in production, you want more than just slap the Java agent on your software locally. You want all apps that are part of the request response chain to participate so you can get the whole story. You also don't want all of those apps configured separately to send it to a particular backend. You want to send it into your telemetry pipeline, which usually means an OpenTelemetry collector. So this is yet another piece of the OpenTelemetry project. It's really useful. You can receive data in like legacy formats for Jaeger and Zippin if you had tracing already. You can run this collector as an agent to collect your logs from files. And then you can process them and convert them into OTLP, lots of different stuff. You can get Prometheus metrics. You can configure it in YAML, not surprising. Does a bunch of things. You can format your data. If you're serious about this, like, being the observability person at work, then you want this book, Observability Engineering, which talks about what you need in a telemetry backend and how this stuff really works. By Charity Major. She's my CTO, and Liz and George. It's a great book, and it has a fox. Overall, I think observability is an important part of what lets us as an industry progress from writing code that works on my box to writing code that actively works in production and increasingly serves users. And it makes it part of the team, and that feels good. It makes me more powerful, makes me able to have a better impact on the world. Okay, we can do questions, but also if you ever want to chat about observability or OpenTelemetry or whatever, I have office hours at honeycomb.io/office-hours. My personal blog is at justitron.com.
Wow. Wow. Thank you very much for such a wonderful presentation. I am like working on observability in our system for last a couple of years. Like second time in observability like back in it, and do hope that more people who are watching us would be in it and would bring this to their project. So thank you very much again for this super presentation. I don't know. I don't have words to be honest.
Thanks. I'd love to hear more about what you do.
Yeah, we can discuss it separately.
I'll take that offline.
Okay, so a couple questions from the guys. So first question is from Andre. It's about third-party services that suppress telemetry headers and that overall trace is interrupted in this case. So maybe you have any recipes or how this issue can be addressed.
Okay, so we're talking about propagation here, and propagation comes in on an HTTP header. For instance, the memeinator in production, my front end actually, that like the React app is using OpenTelemetry instrumentation to add the trace parent header. When that comes into the backend, it's still got the header because I control everything in between. Well, close enough. Amazon doesn't strip it off. So the propagation continues to work. If you were going through a gateway that was stripped that header and took it away, you wouldn't be able to connect your backend to your front end, or this might be in the middle of two backend services, whatever, and get the whole story in one trace automatically. You could do some manual propagation trick to get around that and add the trace context, the trace ID and span ID to your message. And some people do it that way. There are some, Kafka is okay, but there are some queuing software like SQS. I think you have to add it to the message because it won't pass it along for you. And that's manual propagation, and it can be configured. Kind of a pain. Another way you can do that is, have two traces. You can do the usual thing that people do with logs and pass a request ID, which may or may not be the same as the originating trace ID, through and coordinate it that way. You can also make a span link. But honestly, if it's really important that they be in the same trace, I would do manual propagation if I can't configure that third-party service. But the other thing you can do is when you call that third-party service, if this is a synchronous call, at least you're going to see the duration of that. Because sometimes it's a downstream dependency and your stuff doesn't get called back. And then, well, you just see how long it took. And that's invisible. But if you want more, you can come to office hours. honeycomb.io/office-hours. And it's my favorite part of my job, honestly, is answering people's questions about getting tracing and OpenTelemetry working.
Great. Thanks for the answer. Another question was about Spring Web Flux, and you touched it partially in your talk. So question was rephrased in the middle. So the end question is the following. How does exactly the tracing work for reactive apps, and where is the context store when request processing switches between multiple threads?
That's a good question. Actually, Spring Web Flux when you're using the reactive calls, it's a little confusing because I have had to like save the span in a local variable and pass it down in. So it does get tricky. I don't know exactly what it's doing, and I've wanted to figure it out. You can also email me. I'm jessitron@honeycomb.io and give me an excuse to actually spend the time to dig into the details of that, because I haven't dug that deeply into what OpenTelemetry is doing. It's doing something interesting. But the asynchronous reactive style doesn't perfectly work the way I want it to intuitively in OpenTelemetry, because I can like make logs that show up on a span that it's already closed, which is actually a pretty useful thing to do. In Honeycomb, at least, I can see the span, and then that span has finished because it's doing something asynchronous. But here's a log over here that was still in that span context. It's pretty interesting and fun to explore. But sorry, I don't have a super clean answer for the functional reactive programming.
Yeah, anyway, thanks for that. I want just to add about that. So that's great that we have Spring with its magic. So sometimes we don't know exactly how it works. Always we can deep dive there, but yeah, good that magic somehow is working. So another question is, I think it's some pain point for a lot of people who use observability. I will just read this comment because I think it's really important for like a lot of people how to deal with it. I mean, so Tatiana used Tatiana's personal pain point in observability solution is that she used how to choose. It's a problem for her how to choose right strategy and balance of the amount of stored traces logs metrics and memory space that it all eats, right? So we do want to have observability. We want to have ability to dive through that. But next day, where SRE engineers come to us and say, "Hey, we spend too much money on this storage, so we need to clean it up." So maybe you can give us some advice on how to deal with that.
Great. Yes. I didn't talk about cost, and I didn't talk about sampling. So I'm happy for the question. When you're storing logs and you have to store all of them, you kind of look for the cheapest storage you can get. But there's a trade-off between the cost of the storage at that volume and how searchable it is and how queryable. With traces, the best strategy, like the most advanced strategy, is dynamic tail sampling, where you add a step, a dynamic tail sampler. Ours is called refinery, in your telemetry pipeline that accumulates the whole trace and then makes a decision. Do we keep this one or throw it away? So you've got the whole story. You're either going to keep the whole trace or not, or none of it. And if it's an error, keep it. If it's really slow, keep it. That's interesting. And then look at the URL. If it's a health check, maybe keep 1 in 1,000 and throw the rest away. If it's a checkout, maybe keep everyone, or maybe keep 1 in 10, because that's like a critical part of getting money for your business. And the 1 in 10 that you keep, make them be distributed across regions or tenants, so that you get a good even sample. And then when you do that, your sampler will record the sample rate. Like if I'm throwing away 9 out of 10 of these, the one I keep is going to get a sample rate of 10 because it represents 10 requests. And then your aggregators that are deriving your application metrics from the traces can take that into account and say, okay, I've got all these traces. These errored ones count as 1, and these ones count as 10, and these ones count as 1,000, and use that to get the numbers right. I mean, it's always approximate, but metrics are generally approximate anyway. And you can make sure you get a good distribution when you're doing your dynamic sampling really cleverly. And with that, you can also set a target of, I only want to send 1 million events per month. That's too low. 1 million events per week. So sample it to whatever rate is necessary to achieve that target. So that's how you can get predictable costs, and you can tune it to only spend what you want. But then you still have the full story of the errors, and you have enough successful ones to compare them to. I think of it like with metrics, and I'm in this strategy, I'm not even keeping separate time series because time series are fine for infrastructure metrics, but for application metrics, they're never granular enough. They never tell you who it failed for or what the exact exception was. Whereas if you derive them from your traces or your logs, works with logs too, you have that granular data. So skip scoring the time series, that's a cost saver. And then sampling gives you still the shape of the forest that you would otherwise get with metrics, but you can also drill down and look at an individual tree, and you get all the sick trees and enough healthy trees for you to compare them and see what's wrong. Whereas if you only keep logs and you don't have traces, well, if you have request IDs on your logs, then you're okay. But unstructured logs are more like a pile of leaves.
Great. Yeah, thank you very much. So we're running out of time. So I want to thank you one more time for your amazing talk, and thanks for being part of Javon.
Thanks for the really detailed advanced questions.
Thank you. I hope to see you on our future conferences. Thank you. Bye.